Rail welding has been around longer than you might think. In 1895, the Engineer magazine reported on the commercial use of continuous welded rail in the United States, involving apparatus patented by a Welsh-born industrialist, Arthur Moxham. But closer to home, jointed track and the maintenance challenges that come with it remained the norm until the 1960s, a decade which saw an increase from just 343 track miles using CWR to more than 4,600. Welding techniques have of course improved over the intervening 50 years, so too have the rails themselves. All this has helped to drive up track quality. But access is still needed for maintenance, and the time available continues to be constrained by capacity pressures, which is where this machine comes into its own. Network Rail made a commitment to operating 10 mobile flash butt welders as part of its delivery plan for Control Period 4. The first of them came into service in 2012, with the money coming from the £220 million 7-day railway fund, which was established to support schemes offering substantial improvements in network availability. Using the machines, 600 metres of track can be re-railed and stressed in a single 8-hour possession. Previously, it often took 4.
Currently, if we're doing stressing works, before stressing, after stressing, we have a waiting time of about 30 minutes. With this technology, we can weld in track and out of track. We can weld line side in the forefoot. We can weld in strings in a factory setup. And particularly with stressing, which we're doing here today, we only have a waiting time of 8 minutes after we've done the stress weld. And that's basically to allow the temperature of the rail to go below 400 degrees centigrade.
Flash butt welding offers better performance and fatigue strength than traditional aluminothermic welding. The process uses an electrical current, upwards of 600 amps, to generate resistance and thus heat, softening the steel. The machine pushes the rail ends together with a typical force of about 45 tons. They forge when the temperature reaches between 800 and 900 degrees centigrade. A single weld takes 2 minutes, meaning a defective rail can be changed in less than 1 hour. As ever, technology attends.
The computer will record everything that happens within the welding process. So it'll record the pull-up, the forces used, the distance that the rail's actually moved within the welded head. And this is a good way that if there was something to go wrong, you could analyse the graph or the numbers and find out exactly what went wrong, how it went wrong, what time in the welding process it went wrong, and adapt the machine from that to produce better welds.
4 mobile flash butt welders are currently in use on the network, based on a Doosan DX170W wheeled excavator and Holland K945 welding head. 6 more are undergoing approval. Each is operated by a 5-man Network Rail team working 250 shifts in a year. They're capable of working under live overheads and with the adjacent line open, but such use is for the future. Either way, with around 60,000 aluminothermic welds installed in 2012, it's unlikely the machines will be idle for many years to come.